Hey everyone, this is Greg Brown from Foundry, and today I'm going to be talking about Modo, our full-featured 3D animation package. First, we're going to be covering what makes Modo unique compared to other 3D packages. Second, we're going to cover a selection of new features added to the latest release of Modo 15.1. And finally, we'll be interviewing Alan Hastings about how Intel oneAPI Rendering Toolkit has helped with development of our new physically based path tracer, mPath. We have a lot to cover, so let's jump right into it with Rich Urey explaining order of operations in Modo.
Here in your mesh operations list, if you turn on so you can see everything, you can actually look at the different deformers and as they stack up. So the lip curls versus the lip push, lip shaping, cheek puffs, teeth, jaw, so on and so forth. So you can, when you start making a pose, we'll unwind these and you can see how you stack in. We can take the corners, just turn them. We can go through here. Let's take a look at our teeth. And we're going to increase the teeth length. And then we'll play with the fan so we can bring them down. So let's do something fun like this. Let's make the length so they touch. And then this here, we've got a fan fade, which allow you to do this kind of a thing. So now we can get this kind of fun, mouth with big teeth. These circles on all the sides allow you to work on these zones independently. So this one here on the ring brings up everything. So we're working on both mouth corners, opening everything up. But if we go here, now we can look at just the upper mouth open and just the upper lip push. If we want to curl the lip, we can do that here, right? We can curl the front, which I'm only curling the front of that. But then these guys here allow you to have a oops, wrong one. This one, there we go. Now you can do things like pull the teeth out, pull his mouth out so he does funky stuff. I'm enjoying the heck out of playing with this. It's funny, this rig is so old, but for fun, it's kind of hard to beat it. You can do things like this, and then you say, oh, hey, I'm getting some teeth problems. Well, if you go here, there's a base shrink, and you can actually shrink the base of the teeth. Obviously, you're getting some funky stuff going on here with it sliding around, but I don't know. I like it. I'm enjoying the heck out of this rig. So anyway, this is in the standard content. You can play with it. All of these guys allow you to do different things. So if you wanted to grab this and pull the lips up both, or you can grab these individual points and pull them up individually. So we can go here and pull things down, give them the, the clamshell kind of angry look. It's just click and drag, man. So anyway, so that's how you pose it. It's pretty straightforward and simple. The controls, these, like I said, are designed to be individual. So if you want, you could pull his teeth down on this side and up on the other. And then let's take a look at order of operations, because we talked a lot about that. So that's what this is. And if I'm going to turn these guys off one at a time. We're going to go through here. And it's going to take a second to evaluate, and that's okay because it caches them. So the first thing we do is a lip curl, which I didn't do any. Lip push, didn't do any. Lip shaping, yep, did a little bit of lip shaping. Then there's cheek puffs, which I didn't engage. Teeth controls, which you won't be able to tell until his mouth's open. Open his mouth. But then let's say we turn off teeth defs, right? So you can see what's happening there. The corner turns, you can see that. The corner slide, the corner lift, right, which is up and down. So what's cool about this, and where this system really shines, is you can say, I'm having trouble with the mouth corners. So what I'm going to do is I'm going to turn everything off, and I'm just going to look at my mouth corners, both lift and slide, raise and whatever, and see if I can diagnose or figure out what the problem is. So it allows you to build up this sort of layered idea of shaping, and then also allows you to find stuff that could be a problem and diagnose it easier. Also, if you say, oh man, I want to add a shape to the ball guy's face or whatever before he moves his mouth corners up, then you make a new set of deformers and you insert it into the stack to happen before one and after another. So anyway, this is in the standard content. The only things that I did was to make it work nicely with 13.1 is I took the mesh, I converted it to a subd, and I turned on open subdiv. I'm really happy, man. It's moving really fast. So I would be curious to see some people embrace this and do some cool animation-y stuff. It'd be fun. We can do this too. He actually has a ground collision, so he can bounce on the ground. And it all works within the space of the sphere. So if you pick him up and down, he squishes, and you can rotate him into that squish space. So anyway, order of operations, Modo 13.1 with an old asset in Ballman. I'm looking forward to seeing what you guys do playing around with it.
Thanks, Rich. As you can see, order of operations provides a unique, holistic system that can be exploited in a variety of exciting ways. This is a system that we have continued to enhance in the 15 series. So let's hop on over to Laura Embry for a description of some of the new features in 15.1, including enhancements that directly apply to order of operation workflows, in particular for procedural modeling.
If you're familiar with Modo, you likely use the channel haul tool all the time when working, and for obvious reasons. Exposing commonly used channels in the 3D viewport is a huge time saver. So much so I bet you found yourself wishing this streamlined workflow was possible in more areas of Modo. Well, wish no longer, because in Modo 15.1 we're introducing OmniHaul, the ability to control tool or item properties by interacting directly with the active 3D viewport. No more digging around in the peripheral panels for that parameter you keep needing to tweak, losing your flow of work. Now, using the new control icons, you can establish which numerical values you want to control directly with your mouse in the 3D viewport and remain in your creative zone. Need to enter a precise value for the active parameter? Just hit the Enter key for quick input. Do you sometimes find a tool's properties panel filled with so many options it takes longer than you prefer to find a setting? Now you have a mini properties panel conveniently mapped to the space key, containing only the tool's most used settings. You'll see your speed and proficiency skyrocket when adapting OmniHauling into your 3D workflow. One of Modo's core philosophies is enabling creativity without needless complexity. As more design-oriented users enter the 3D realm, we see an increased need for modeling workflows that focus on the larger form creation rather than tweaking vertex points. Designers don't want to think about topology. They want to think in terms of shapes that can add or subtract from one another, and curve booleans will enable them to do just that. Using the curve boolean toolset, you too can rapidly iterate on shape creation in Modo by simply adding, subtracting, or intersecting curves regardless of the curve type. With the new workflow comes the need for easier preparation too. So we're also introducing the Curve Winding Aligner procedural operation. This handy tool gives you total control over a curve's winding direction, so setting up your curves for later operations is more straightforward than ever. And our Boolean CSG operation has a new mode, Union All. This mode unites all the polygon groups in an active item layer without the need for a driver mesh item. When you select multiple item layers, the union result will be applied to the primary active mesh. Modo's procedural toolset empowers you with a non-destructive approach to modeling, letting you change the order of operations at will. This is easily visualized in the MeshOps viewport, but isn't as clear in the schematic viewport, where it's not easy to see the relationships between operations and items at a glance. Enter the MeshOps stack node. This pragmatic node displays your operations in a stacked view, just like the MeshOps viewport, making relationships between a stack and the node graph easier to understand, edit, and develop, all in the convenience of the schematic viewport. It will help you manage your node graph links. For example, instead of having multiple links exposed from a mesh item in an assembly, you can use the MeshOps stack node to reduce this amount to one link. That's much better. The MeshOps stack node helps you streamline your node graph too, by enabling you to apply an order of operations to multiple items quickly and easily, and reorder them at will. You can nestle MeshOps stacks inside larger stacks for more precise control. And you can also connect multiple MeshOps stack nodes to a single item, saving you valuable time by removing the requirement of duplicating operations for different items. We've also given our merge mesh operator a very handy update. There is now a drop-down menu that lets you choose a specific layer of a source mesh's stack to merge, so that only the selected operation and the operations below it are applied to your merge geometry, rather than applying the entire final evaluated mesh. Mesh ops allow for modeling operations and deformations to be performed in a sequence, and each operation can be modified at any time in the creation process. While this workflow empowers you with a non-destructive approach to modeling, it also means that when a change occurs, every operation in the stack is re-evaluated. This creates performance challenges when a stack becomes large or contains many operations. Deferred evaluation makes modifying channels anywhere in the stack more interactive by deferring the update through the stack until the user releases the mouse, producing a more comfortable experience interacting with complex mesh op stacks. If a user is modifying channels on a mesh op, that modification affects operations that are above it and the entire stack is re-evaluated. When enabled, paused evaluation disables all evaluation, allowing a user to quickly make a couple of adjustments that won't update until pause has been disabled. Furthermore, deferred evaluation can be leveraged on deforming surfaces to temporarily replace a high-res mesh with a low-res stand-in mesh when deformers like bones are being manipulated. This allows users to rapidly edit deformers with high interactivity and without sacrificing visualization of the high-res mesh. Modo's native Empath renderer continues to grow in capacity with this release. There's several updates to show you, starting with chromatic dispersion support, which is the rainbow effect that can occur when light refracts through a transparent surface. Secondly, Empath has an interactive viewer called QuickCam, accessed through the Alt and F9 shortcut. Similar to Modo's native preview render view, QuickCam will run Empath with infinite iterations, allowing you to adjust your camera with interactive updates. The camera view can be rotated directly when using the Alt key with the right mouse button, making its control consistent with the preview render view and OpenGL viewports. We've improved the overall performance when using light linking with Empath, and lastly, Empath now holds a denoised image after completion. It does not clear it per iteration as it did before. This gives you better visualization of your final render when you're using Empath.
15.1 is now out in the wild, and we'd love for you to take it for a spin. Now let's talk about our renderer, Empath, and how Intel's oneAPI Rendering Toolkit has helped Foundry rapidly add new features to Empath. The creator, Alan Hastings, has been kind enough to take a break from making amazing things and chat about his experience working with Intel technology. Hey, how's it going, Alan?
Going good.
Awesome. Thank you so much for joining us today and kind of capping off this presentation for Intel. But I was kind of thinking as we were putting this presentation together, you were the right person to speak to in regards to Intel oneAPI, because an artist like myself, oneAPI isn't marketed towards me. It's something that benefits me as an artist, but you're the person who has to actually use these tools. So your input on this would be incredibly valuable.
Sure.
Awesome. All right. So you have extensive experience in CG in general and in creating renderers. When did you start programming renderers?
Not long after I first learned basic programming, which is the late 70s, in junior high. And I got a Commodore PET home computer as a Christmas present in, I want to say, 1978 or 79, and immediately started doing graphics on that. I had a special add-on board that would allow wireframe 3D graphics, and I used that for some Super 8 sci-fi animations. So that's my first, I don't know if you'd call it a renderer, it's just black and white wireframes, but it was a lot of fun.
Gotcha. How did you display that? Like, was it on a monitor? Or?
Yeah. I would just set up the Super 8 camera pointing at the PET monitor in a darkened room and shoot off single frames at a time. Get the film back in a week, and you can watch it on a movie projector.
Wow. So was that inspired by the Death Star fly-through scene in New Hope?
That's kind of what it looked like. Yeah, that was the effect. And I would cut that into my Super 8 films using models and other, claymation, other effects.
I do have a few images that I'm going to pull up here that I'd like for you to kind of give a little bit of explanation on. This is some of your early work.
So this is the Commodore PET wireframe graphics I was talking about. This is a
awesome
view of flying into a space station, much like in 2001. And it's a computer model of a actual plastic model that I had built, used in the other scenes. So this is what the pilot would see.
Very cool. All right, and here's the famous graph paper images. Yeah.
Yeah, so for all of these early projects, I did not have any sort of modeling program. In fact, one did not even exist. So to get the actual geometry into the system, I would have to type in as a text file all of the XYZ coordinates of all the vertices.
Oh.
And so this is a scaled drawing that I did of an Apache helicopter, and I could read off with graph paper the XYZ coordinates and type them in.
Very freaking cool.
There's various moving parts like the helicopter blade. What you see in the upper left is a helicopter blade with a couple of transparent sections in front and behind it, which are for fake motion blur.
Oh, awesome. All right. And here's the one that always freaks me out with all the actual indexes.
Right. So once you have all the XYZ coordinates, you then have to tell the system how they're connected, which means every vertex has an index. And you can say a polygon has 4 vertices, and then you type in their indices. So that's the second half of the text file. So yeah, this is how I did modeling for many years.
Man, I thought I thought I had older information in that. I'm like, you guys don't know how lucky you are to have sub Bs, but it's like, this is, you don't know how lucky you are just to have something that can draw 3D geometry on a screen to begin with. So
yeah,
that's incredible.
This probably dates from 1986.
Wow. That is amazing. And yeah, and here another 2 of them that are just fantastic. Well, I'm consistently amazed by those images every single time I see them. It's, as an artist, oftentimes we imagine programmers just going off into a corner and just making something that we can't fathom. But you actually come from an art background, and your motivation being art, so it's very relatable, and I think it's extremely cool. So our first foray into leveraging Intel's oneAPI rendering toolkit here at Foundry was Intel Open Image Denoise, I believe, right?
Right. We, I started on Empath, the second, the new Modo renderer, about almost 4 years ago now. And one thing about path tracing is it's got a lot of advantages, but it has one disadvantage, which is the images can be noisy. Well, they are noisy at first. And to clean them up by purely adding more paths, more samples per pixel, can just take too long. But fortunately, denoisers exist, which can intelligently clean up the image. And the Intel denoiser was, the open image denoise was highly recommended. And so I gave it a try, and it actually turned out to be a lot easier to integrate than I thought. I think I just did it over a weekend. And the results are really nice.
Yeah, no, it's we're definitely very happy with Intel Open Image Denoise. It was a great multi-platform option for us, so that users aren't locked to hardware, and a lot of our users really recommended the Intel denoiser, just the reliable quality that they were able to achieve from it. And you mentioned Empath earlier. That is our latest renderer in Modo, and what is Empath? And I ask because it doesn't seem to fit into what I as an artist thinks of in regards to a renderer. Currently, we support 3 ray tracing kernels in Empath, and Intel Embry is one of those. Can you elaborate on that a little bit?
Sure. So like I said, the original Modo renderer has been pretty well proven. but it's a more traditional design, which is based on recursive ray tracing, where you'll fire a ray, you'll hit, from the camera, you'll hit a surface, and you'll shade that hit point, and shading that might require firing a lot of additional rays. And for each of those, you have to shade all their hit points. But the shading and ray tracing are closely interleaved. And basically what it comes down to is you can't really take advantage of really accelerated ray tracing. To accelerate ray tracing, it's much better to have a large batch of rays and trace them all at once. Well, that just wasn't really going to work. I was able to do it a little bit in the old renderer, but in a path tracer, one of the advantages is that you can divide up the work into very large batches of rays and then very large batches of shading work, and sort of alternate these two phases. So that's one of the advantages. Just to get into another reason why we went to Empath, the controls are much easier for the artist. There's much fewer settings required for a path tracer. The old renderer was getting just too complicated. Hard to maintain the code and hard for artists to set up all the settings unless you become an expert. With Empath, it's much simpler. There's basically one primary quality setting. Another advantage is that path tracers tend to be better for physically based rendering. Empath is very good at tracking, for example, changes between the index of refraction as a path travels through multiple materials. So you can get all that just right. You can also do things like light path expressions, where you can have render outputs that show just the effects of one light source or a group of light sources, or all the rays that have bounced off one particular surface. So those are some of the motivations, but one of the nice byproducts is having these big batches of rays, and that allows us to use things like Embry, which is built to take large batches of rays and compute them with taking advantage of all of your SIMD, all your cores and all the SIMD on each core, which means you're just doing a lot of math operations all in parallel. So that was quite a significant speed up once I was able to integrate that into Empath.
Very cool. So the Embry kernel is part of Intel's oneAPI. Was it easy to leverage? And what are your thoughts on this technology?
Yeah, well, once I had done the open image denoise, that turned out to be easier than I thought. So I actually launched into integrating Embry I think the next week. And the process went much more smoothly than I thought. I started out with just triangle meshes, and then I extended that to handle instancing, and also transform motion blur, where each mesh or instance can be spinning or translating. And then the final step was supporting our hair and fur, which required Embry offers a number of different primitives that can be used for hair and fur, and they had one that was very close to what we already use in Modo, which is like a series of cylinders with round ends.
Yeah, it was kind of funny, seeing you work on this in the background. So I'm like, oh, cool, we got another denoising option, and then I heard that we were working on adding the Embry kernel, and it's like, okay, we'll see that eventually. And it was just incredibly rapid when we saw that brought in, and also we were all very surprised at how many of the native rendering features were supported in it, and how rapidly that happened. So it was really impressive to watch.
I was a bit surprised by that too.
That's a good thing. Based on your experience using oneAPI, is there any other technology in the rendering toolkit that you're possibly keen on taking advantage of in the future?
Yeah, well, one thing Empath does not yet support is volumetric effects. And so I definitely want to look into what oneAPI offers in that area.
And how supportive has Intel been in implementing the oneAPI tools?
Actually, great. I've only had a few questions for them. But the most interesting thing that happened was during while adding support for hair and fur, I noticed that their cylinders, these cylinders with the rounded ends, that was only rounded on one end of each segment, and that didn't really match with what we were doing in our original Modo hair and fur. So I told them about this, and it didn't take too long before they came out with a new version that added exactly the option that we needed. They rounded on both ends. So that was fantastic support.
Can't thank you enough for that interview, Alan. As you can see, Intel has developed a powerful package of technology that is easy for developers to leverage. We're very excited about what we can add from oneAPI in the future. We're rapidly running out of time, so I'm going to leave you with our overview video from the latest release of Modo 15.1. Thank you, Intel, for the amazing tech and support, and thank you to Rich Huri and Laura Embry for the excellent demos. And with that, here's Modo 15.1. Modo 15.1 is here, and it's ready to enhance your everyday. The second of 3 releases, 15.1, has been built to improve how you create. The introduction of OmniHall, curve booleans, deferred evaluation, static analysis, and the MeshOps stack node provide valuable new tools that will accelerate any workflow. Now sit back and take a look at what we've added so far during the 15 series.